Good evening. Maybe this is probably the end of the day. I see people are coming, and then today, it's going to be more of a demo. I'm not going to talk more. I'll leave the slides to you once the session is done. You can just read through the slides. I'll just rush through a few slides for reference. And it's more of a demo. How do we deploy a Spring Boot app on Kubernetes? And the techniques. And finally, we touch upon how do we add Istio spice to the Spring Boot application. Okay. Just a bit about myself. I'm a director of developer experience at Red Hat, an active open source contributor for OpenWhisk, Eclipse.js, and Fabricate platform. And I'm creator of the Vertex Maven plugin. How many of you know Vertex here? 1, 2, 3. Great. If you have any questions, please feel to get on to my social handles here. So I'll be happy to answer your questions. I'll also have the demo repositories put down as part of my summary slide. If you face any issues, you can log the GitHub issues there. I can be able to help you out to resolve the issues. All right. OK, this is with love from Red Hat developers. So we have these many free ebooks downloads. If you go to developers.redhat.com, I have those bit.ly links on top. You can go there and then download the books. So they teach you various many things, microservices, Istio, and then reactive services, and probably Edson have given you on microservices DB as well. So there are also some other basic materials, the links to those material instructions which we have built to help users to get onto microservices. Right. So before we begin into the demo, I just want to give you a short overview of how the microservices evolved over the time until Kubernetes was born. We started with the continuous integration in 1999. Then we have released the Agile Manifesto. We saw what Agile is all about. Then we had the EC2. I could call this first milestone in microservices development, the EC2 deployments. And then we had the DevOps era starting up. Then we had Java EE6, which modularized a lot of things for us, made easy for Java developers to do Java development. Netflix, kind of what you call, added more fuel to the EC2 engine, making more microservices more prominent in the industry. Then we had the first Java microservices framework called as Drop Wizard. That was in 2011. Then we had Ribbon, which is used for client-side load balancing, 2012. Hystrix for circuit breakers again. Gave some formal definition to microservices from ThoughtWorks. Eureka for service registry. Spring Boot, that's something which you're going to see today. So he made a big revolution in the microservices world. He started to do, he added all these Netflix components like Eureka, Ribbon, and all these stuff, made us jars available to you to develop your Spring Boot applications much faster, quicker than you to deploy each and every component. And then we had the containers, which again revolutionized. I could call this milestone 2 after EC2. Containers is something which is kind of revolutionized how do you do microservices development, right? And then after that, we have this formal definition of microservices given. So we'll see that in the next slide, what it's all about. And all famous Kubernetes was born on June 2014. So that's where we are today, where we want to start doing, how do I do Kubernetes? How do I deploy Spring Boot on Kubernetes and all this stuff here today, right? So this was a very formal definition I put down here. So just to say in 2 lines or 2 words, I could say it has to run on its own process, and then it has to be automated deployment machinery, scale up and scale down, talking to external world using HTTP kind of a protocol. So we will see how this matches our scheme of things in microservices world. So when I say microservices with EC2, Kubernetes, containers, or whatever you call, end of the day, it's nothing but distributed computing. So I have a bunch of JVMs, VMs, containers running in multiple places, talking with each other, so which is making you what we call as microservices today, right? So when I get distributed computing, which means that there is a network of services. So as my application keeps increasing, I'm keep adding microservices to my application. Then what happens, it becomes a big mesh of services talking to each other, having its own complexities, having its own properties. All right, so if it's network of services, and this is what we say that what properties a typical microservices should exhibit. This is not the entire stuff, but these are the very basic ones that any microservices should have then to be called as a microservice. So we have API, we have discovery, tracing, monitoring, lots and lots of stuff, and then we have the frameworks which helps us to do sitting in between, like Vertex, Spring Boot, Wildfire Swarm. We call them as Thorntail going forward. And then we have Go and Node.js, so which helps us do microservices development, but around these properties. So any microservice that's developed should have all these properties inherently. So let's try to map these with what Netflix and EC2 gave us earlier. So the very early of things, these properties were kind of tackled by Netflix. Netflix giving us discovery invocation via Eureka and all these stuff. And then we have AWS giving us resilience and all these stuff via EC2 computes. And then Zipkin for tracing. So this is very basic beginning of how we start to map microservices when we start developing that. But what happened is like after Spring Boot was there, then I'm just going to run these things a bit. So what we had is like this was a typical 2014 after Spring Boot came into existence. So this was more or less my de facto platform for deploying microservices. So I have Eureka for registry, config server for maintaining configuration, Zipkin for tracing, and the Netflix Ribbon for client-side discovery, all sitting on Spring platform. So you could call it any platform you want. But I have my own reservations for this coming with the technologies that we have today and what technologies we do today, and with Kubernetes, OpenShift, and all these technologies. I feel that Spring Boot is awesome even today, but it lacks in a few things which I jotted down here. Probably I will call them as constraints. One is managing on multiple hosts easily. It means that the perception what I give here is not that it cannot be done. It could be done better. So that's the whole idea. So manage on multiple hosts. And then how do I happen like when some host goes into trouble? How do I recover it back? I stop deploying application to that. I move to different ones. And then how to scale automatically. Like for example, I deployed on a node, I should measure my metrics, my CPU, my disk usage, and automatically start deploying applications to other nodes. And then I have a desired and actual state. For example, I have a cluster. I have for example, let's say a zookeeper. And then I say for any given point of time, my zookeeper should have 5 instances any given point of time. So how do I maintain my desired and actual states? Say when some server goes down, I should automatically take care that something pops up and comes up, right? And then how to avoid port conflicts. So with VM-based deployments, when I deploy 2 VMs and I deploy 2 application microservices on the same VM, then I'm subject to that, like there will be a port conflict. Though I can avoid it, but still in some cases, if I don't want to avoid it, then how do I do that? And how do I update them? Meaning the update here is more towards the application. It's not the infrastructure. So what I'm talking about is all around applications. It's nothing to do with infrastructure. So how do I update or deploy my new versions of the application seamlessly? And finally, so where are my containers? So we are in the container world. So where is my container? So where is my container in my microservices architecture? So I don't have it today. So these constraints made me think the Spring Boot, Netflix OSS, as of today, is kind of a bit of a caveman's architectures, and then I would love to move to this area, right? So I want you to take a time wrap and then move to a new world where all the technologies, which is lovely technologies we have today, and apply them on top of Spring Boot to make your applications much more faster, better, and than what you were doing yesterday. Okay. The 2 important technologies that helps us to do this is OpenShift and Kubernetes. And probably most of us know what Kubernetes is, and I'll tell you what OpenShift is. OpenShift is nothing but it's enterprise Kubernetes. So what we have done is like when you take raw Kubernetes, so when I want to deploy it on an enterprise, so we from Red Hat, like we took the distribution of Kubernetes and still we upstream a lot. And then we added some enterprise-y features like Jenkins, microservice, your MQs, and then we have some cluster storage, Wildfire Swarm, and what possible enterprise applications onto it, make ready to be containerized and deployed. So that's where we call as OpenShift, and then we release 3 different flavors for the typical enterprise, so who needs support to deploy Kubernetes on real enterprise environment. But having Kubernetes come into existence, so let's see what Kubernetes done to us to our old hexagon what we had. So I just kind of replaced the discovery, invocation, elasticity with Kubernetes. Kubernetes can do me naturally without any additional stuff being deployed. And then with Netflix, with the OpenShift, I can add monitoring, logging, and then in fact authentication, and then I can add pipeline. So which makes this a complete enterprise-ready deployment of my microservices architecture. All right. So this is what your default Spring Boot application is going to look like when I'm going to take it to a Kubernetes environment. I'm still going to use the same old app jar, Spring Boot run app jar which you're using. And then instead of running it on a VM or instead of running it on a separate machine, I'm going to containerize that and deploy it on a container. Right? And then Kubernetes is going to take care of how to orchestrate and deploy my applications into the platform. Right? So let's quickly see how do we deploy this. For this quick demo, I already have an application. So these are the 3 tasks which I'm going to do. I'm going to do a Maven package, and then going to do a Docker build, and then finally I'm going to do the Kubernetes manifest application and get the application deployed. Okay. So let's quickly get into my demo. So how clear is the screen visible, or I want to increase the font? Is it okay? Fantastic. So my application is going to be pretty simple. I'm going to have 3 different microservices, just the notes which I made for copying the commands. So I'm going to have a customer application. It's a simple microservices application, kind of a more or less an allo kind of stuff, which is going to talk to preferences and which is going to talk to recommendations. So what we see at the end of these demos is that the last demo of the day, like I'm going to show you like how do we route based on percentage of network traffic. So which is not possible with existing very easily. So I'm going to use Kubernetes plus Istio. So how many of you know Istio? 2, 3. Service mesh, OK. I'll give a short introduction, and then maybe I can just run on that. All right. So let's quickly get on to what we do now. Just going to do clear. Just going to create a dummy project. I'll show you what it is in a moment. So I got this project, and then I have to go to my first microservices, which is there I am right now. Okay. And then I'm going to build this application. So I'll show you the application, what it is. It's very straightforward. There's no big logic in it. It calls another service end of the day. So if you see customer controller. So if it's not a pretty big application. It has one REST service, which is going to talk to 2 different applications end of the day. So one is the root path, and one is this is just a test, which I put down here to see how the deployment works. So, and then it does not have anything additional to this. It's a very simple application. So I'll skip explaining about what these are all, and then jump to the deployment. And then, as I said, my second task is that I have to do a Docker build. So I would make these jar ls target. So I have this generated jar, which is nothing but your Spring Boot jar. I can still run java-jar and run this customer jar. It's going to give you the same output. So I'm going to Dockerize this. If you see my Docker file, so it's nothing but it's a very simple Docker file. I'm having a bunch of environment variable for Jaeger. I'll come back to Jaeger soon. And then I'm just going to do a simple copy of this customer jar to deployment, to the container. And the container is going to start do java-jar by default so that your application is up and running. So my second task for my demo is that I have to do a Docker build. So I'm just going to do the Docker build now. Okay. This is a very common error you used to get. So I said, say, Docker env. I have to set the daemon pointing to that. And then now I say, so and then I do Docker images, and then say grep customer. I got my images built now. So and then I have to do a Kubernetes deployment. I just show you it's a pretty normal Kubernetes deployment what I have. I just say number of replicas of my application that has to run, bunch of labels for the service to pick it up, and then I'm also have a control of how do I spend Java options here. So the base images I'm going to use is also going to help you to avoid the C groups issue that you usually get with Java. So I'm going to give you those options as well. And there's a bunch of usual Kubernetes ports that being exposed from the command. So I'm just going to do that right now for you. So I just go there and then say, OK, deploy my application. So before that, I want to show you, I'm sorry about this resolution. I'm not sure what I'm going to do with the resolutions now. OK, I have to bear with the resolution now. So I don't have any application. This is my the project which I created. It's nothing but a Kubernetes namespace. In the namespace, I don't have any application deployed right now. I'm just going to do the first application deployment right there. So I'm just going to say, OK, go and deploy my customer application. And the moment you see this application is getting built here. So it's getting deployed onto your thing. Let's give a couple of minutes, and then I can also watch. OC. This is default Kubernetes commands. I'm just using OpenShift commands, command line tool. Right. So, and you see that my application is running. So my application is deployed, but I don't have. You'll be wondering, like, how do I access this application? So right now, there is no way by which we can access. I'm just going to do this. So once my application is deployed, I need to create something called as a service, which is nothing but your Kubernetes service to access the application from outside world. So that's what I'm going to do now. So I'm just going to say, OK, go and create my service. All right. So now if you see, I got a service. For now, the service is internal, which means that I cannot access a service from outside world. Right? So that's something which I have to do right now. So which I'll be doing, like, I just say, OK, go expose service. My service name is customer. I'm just maintaining the same name. The moment I say this, you see that I got an URL to access the outside world. So this is one of the big differences which I have to call. If you take a raw Kubernetes and what OpenShift does, that is, OpenShift gives you by default a router which is running inside that, HA proxy, so which can create you automatically these URLs for you to access application from outside. So this is what we technically mean is one of the enterprise features. We say, OK, when you use Kubernetes, I have to build all these stuff myself, but now I can do it by OpenShift. It does most of the things for me. I just need to type a couple of commands. I'm done. I'm ready to roll. All right. Let's try accessing this. Boom. So I don't have the other applications available for me yet. Right. So how do I do this? So you'll be wondering that earlier, if you see the earlier one on the presentation, we saw that Netflix was kind of controlling stuff for me. Right. OK. That is going. Right. So Netflix was kind of controlling stuff for me earlier. If you see the old slide, just flipping back. He was doing all this stuff right now, and then you have Netflix components like Eureka, Ribbon, and all these stuff doing my service discovery and API invocation and all these stuff. So now with the advent of this, come on, just need to flip it. So I have deployed this, How do I do that? So how do my platform changes? So we have seen that we deployed the application, my application is ready, only one piece of it, the customer alone. I have 2 more applications to deploy. So this is what your platform looks like. Maybe starting in 2017, which we did. So we are going to replace Eureka with Kubernetes services, because Kubernetes by default gives you service discovery. So every application that is deployed on Kubernetes is discoverable. So I don't need to deploy a service registry to register my applications and deploy my applications. Right? And then I'm going to knock off config servers with config maps. I'm not going to cover about config maps today, but you can just Google that out. And then Netflix Ribbon, I don't need load balancing, because load balancing is again going to be done by Kubernetes automatically. So by default, it load balances between your services. We'll see that in the demo. So Zool, Netflix OS is still, I'm not using Zool for this example. They're still there. And then the one big change is that I'm deployed on an OpenShift platform. You've seen that I was deploying on a Spring-based platform earlier. So now and then I have to convert that into a VM and then deploy the VM in your cloud infrastructure. But right now I don't need to do that. I just deploy OpenShift. OpenShift does the other stuff for me, as we've seen just now. Right? OK, so let's do the next demo. We'll do the API and invocation. So what I mean by here is that I'm going to show you how to avoid this nasty error which we got some time back. So what I'm going to do is, like, I'm just going to go back to the preferences, which is in my next microservices, which you don't see. I'm not able to reach preferences here. So what I'm going to do now is, like, it's the same set of commands that I'm going to do. There's no big different changes to the commands. I'm just going to do maven clean package. And then I say do the Docker build. And then let's verify the images, Docker, grep. And I have my preferences application deployed. It's again a same Spring Boot app. And then I have to do the same tiny little thing here. So I have to say deploy my app. It's again going to be deploy the app, but only thing is that I'm going to use a different Docker container. It's the same deployment, but different containers and different labels. And then you will see this application getting deployed in OpenShift now for you. The pod is coming up. The pod has come up. Still one more thing I have to do. What I have to do next? Service? Excellent. So I have to go take the service, make it available for my application. So I'm just going to do that. The service is ready. So now if I go do this, we'll still expect one more issue, that I'm not going to be able to connect to recommendation, which is my next application, right? So customer talks to preference, preference talk to recommendation. So what I'm going to do is I'm here for convenience. I'm already there on recommendation. So I'm going to show you two different versions of recommendations. The whole idea is that I want to show you how routing of traffic happens, because Kubernetes by default does a round robin, 50-50. We'll see that in the example, and we have to have something like a service mesh like Istio to make it deploy. For example, I want to do 75-25, 50-50, or some kind of a thing, right? So we'll see about that as well. So for the first example, for us to make our first demo complete end-to-end work, I'm just going to do clean package of this. I'll just pull this up a bit so that it's easy for you to see. And then I'm going to build the first version, which I call as V1 of the application. So the V1 and V2 does not have a big difference. Again, I have to do these two things to connect to the Docker daemon. All right. So my first thing is done. Then again, I have to follow the same old process of creating the deployment. Let me see if my deployment is getting created. Yes, there you go. So my first version of the V1 of my recommendation is getting deployed. And then what I'm going to do now is that I make it available as a service, right? So now when I go to my browser and say this, there you go. So my customer has talked to preference, my preference has talked to V1 of the recommendation, right? Which I'm just made a differentiation to show you two different versions of V1 and V2. Right? Now, if you see the deployment which we made right now, so I don't have Eureka, I don't have Netflix, other components deployed, because all of the components has to be deployed in your platform for your service registry and discovery to work. That's the traditional Spring Boot deployment. Right? So when you take it to Kubernetes, I can avoid those pieces of components because Kubernetes already gives me all those stuff, but it's not so sophisticated. That's why we want to add something like Istio later. But still, I'm able to do this invocation and everything pretty easily. Does it sound easy or tough to you? Easy? Maybe the bit of learning curve, probably I should say, is that how do we write Kubernetes manifest, but there are tools which can generate that for now. It's not like how it was earlier. So it's going to be damn easy that my application is going to still same. I'm just going to have jars. I'm just going to, the way I package them as container and deploy them into Kubernetes. That's it. Right? So let's quickly go and see, like, what I'm going to do right now is that I'm going to change the recommendation controller. I'm just going to make a quick change. I say V1 and V2. I'm just going to change to V2. And then I'm not going to deploy it yet. I'm just going to do a build. I'll come back to deployment a bit later. I just do Maven clean package. And then I come back to and then build the version 2 of the Docker image. I'll just show you what it actually does. So if I say Docker images and then grep, I have two versions of the image. I'll show you how the traffic gets routed there. So before that, I just want to show you some theory around that, what it makes. So we're done with this. We have made an end-to-end API discovery and invocation. We saw how to deploy applications and all these stuff. But still, we are not done. So we have some fundamental problems when you start deploying microservices. Right? So we have registry discovery issues. We have distributed tracing issues. We have circuit breakers issue, because this makes your application, making it typically Java-based. It cannot be a polyglot application. Right? So that is one of the things. And then we have the operational requirements that how do I do a CAN release? How do I do rate limits? How do I have access policy? So these doesn't come out of any platform out of the box. We have to start deploying multiple other softwares to do it. But with the advent of service mesh, which you're going to see, so it's going to alleviate much more problems for you. So which you'll also see over the demo. So the only wrong which I see with Netflix OSs is just Java-based. So in case if I have an application which is Node.js, and then I want to introduce tracing, then I have to write Node-based tracing kind of stuff, which is going to deploy there into Node application to make tracing work, right? If you've seen this, I'll come back to the browser and show you how tracing naturally works in my platform. So what you have done is like we have still maintained the old platform. We've seen that we have just added Jaeger on the right corner of the thing, which you see, which is going to help you out doing all the tracing stuff. It's already deployed. I can show you the console of Jaeger. And then I'm going to replace this Netflix OSS stuff, circuit breakers, and all these stuff with Istio. So with Istio service mesh, I'm going to get a lot of things out of the box, what I'm going to show you soon. And then my platform still remains same. There is no change to my underlying Kubernetes platform. My Kubernetes platform is still going to be OpenShift. I'm still going to do the same thing what you have done so far, but we are going to get some additional power to my application, right? So what I'm going to do is like, I'll skip these slides because they are just pure theory, so you can just watch it out later. But I'm more interested to show you this. So traditional deployments, what we made right now, it's by default Kubernetes does a round robin 50-50. I mean, between V1 and V2 of services. We'll see that quickly. What I'm going to do, I'm going to deploy a bunch of Istio rules, so which is going to do all these things. For example, customer talking to preferences. In one version, it will be 75-25 distribution. In one version, it will be 10-90. In one version, for example, it could be even based on a request headers. Let's say I want all Chrome users to go to this one and all Safari users to go to one other thing. This is usually useful when a company is releasing new version of the application and they want to test it out with the different browsers, if it's A/B testing, probably. So, and then it can also help you trying out new features with only one set of customers, right? This is not possible with by default Kubernetes platform for any given application, but we are going to spice up our Spring Boot application to do all these work as well, right? So let's quickly switch back. So to the browsers, and then I'm going to show you. So if you're seeing this, for the sake of time, I've already deployed Istio into my thing. I think the instructions how to deploy Istio is there in my GitHub demo repository. So you can go to my demo repository, it says you how to deploy Istio. So we're not going to get into deep details of Istio here. So if you go to Jaeger, which is by default is deployed as part of the distribution. So I'm going to do some traces in the last 1 hour and find some traces. So you see, I have a bunch of traces done. So these are the errors which we got earlier. For example, I was not able to reach out to the preference service because it was not deployed. It was unreachable. And then if you go back, and then I was able to see the all good day spans, right? The spans kind of shows you how your tracing goes from customer to preference and preference to recommendation, right? So we got all the stuff right there. So Jaeger tracing comes out of the box when I deploy Istio, which means that's one of the features, the properties which you saw for microservices earlier, that I need to have tracing by default for me. All right. So how do we do that? So it's going to be pretty simple. It's not simple in sense, but I made it simple. So what I'm going to do is like I already deployed recommendation. So the first thing I have to do is like I have to deploy the V2 version of the recommendation first. So if you go back to our console, and if you see the OpenShift console, I have in my tutorial project, which we saw preference recommendation. I have only one version deployed. What I'm going to do is like I'm going to deploy the second version of recommendation. So it's pretty easy. So no big change. Copy paste. Just change the labels to this, right? And you'll see the second version of recommendation getting deployed. So I'll wait for that because Istio uses something called as sidecars. Maybe you can just, I'm not covering sidecars. I saw somebody was talking about Istio earlier, so I just took the benefit from that. The Istio sidecars acts as a proxy between your services and then intercepts all your requests to do all kind of routing that is required, right? So what I'm going to do right now is that I'm just going to apply a bunch of Istio deployments. So for each of these applications that we have deployed earlier, so I'm just going to apply, make it Istioable. I'll tell you what I mean by that. So whenever I deploy Istio, there will be 2 containers which will be deployed. So if I do OC get pods, so you'll see that each of these applications gets an additional stuff like 2 by 2 or 1 by 2 kind of running for you, which means that the Istio deploys a sidecar into your Kubernetes, which helps you to do all of other things which you just saw, now getting the tracing out, getting other stuff out. So if you see the examples, for example, in any of the code which you see here, so I've not added even a bit of tracing code here, except passing a bunch of headers. Right, even that we are not doing it with Jaeger library, Java library. I just need to include that. It automatically propagates the headers for you. So there's nothing tracing specific here. So if you're seeing the older applications, I would have run a bunch of code just to do create spans, close spans, open spans, delete spans, and all these stuff. I'm not doing anything here, right? So let's see, this is running, and then I'm also going to deploy V1 and V2 is deployed. Okay, I'm just going to apply the same thing for this guys, the preference application as well, so that it's also getting initialized now, and then I have to do the same thing for the customer, right? Which is literally I'm making these applications Istio ready, which means that it's service mesh ready. So the moment I make this application service mesh ready, so let's see if all my parts come up. I'll show you some lovely stuff which it does. So let's wait for some time. Yeah, good. So if I do this, I have a small script which just polls. So I've not applied any rule by default. I'm just going to do a polling of the customers. I mean the customer endpoint, which is my REST endpoint. And then you see that by default, it's V2, V1, V2, V1, V2, V1, right? I've not applied any rules, which means by default, Kubernetes distributes you have two versions of the services, recommendation services. So the applications get distributed by default to two by round-robin fashion, which is not helpful, which is not sophisticated, okay? So what you're going to do right now is that I'm going to make it a bit more interesting. So I just go apply, let's see, apply. So again, I'm just going to apply these things, route rules. So which one you want to do? Your choice. 50-50, 75-75, 20-25, all V1, all V2? Okay, I take my choice. I'm going to route everything to V2 by myself. Okay. I love the V2 version of this. So now once I do this, what happens is that I'm going to run the same poll consumer. Boom. There's no more V1 in my routing. So everything goes to V2, right? So I just want to do a change to this. I just delete the old route. I just say istio ctl get route rules. And then I'm going to delete this. So all these commands are there on the tutorial, so don't worry that you're going to miss anything. You're not going to miss anything here. FNN, I have to tell which namespace it belongs to. Delete, okay. Sorry, my command is wrong. Okay, I don't have any route tools more left with me. So what I'm going to do now is I'm just going to apply a new route rule. So I'm going to do a V1 and V2 75-25. Yes, please. Can I have the mic, please? Yes, fantastic. I think I'm about to show that. So for this, so I'm just going to, okay, let's say, if you see this rule, this is nothing but is another Kubernetes manifest. I'm saying that I'm routing it by labels. I'm saying that go to the version V1 and wait 100%, which means that route all my 100% of my traffic to a service which has label Kubernetes label V1, right? And then I'll show you the other one which I'm going to apply is 75-25. This is a distribution. What I'm going to do is like 75% of my traffic is going to go to V1 of the recommendation service, and 25% is going to go to V2 of the recommendation service. Right? So this is the same rule, but so if you see that the labels is what is going to play a big importance, that whenever I deploy my Kubernetes applications on a service mesh like Istio, I have to be very careful that the labels is also going to play a big role for us. Okay.
But you define that labels in
Yeah, so service, the labels are there in deployment, yeah. So if you see the this file, the labels are here. Okay, so that's a Kubernetes, default Kubernetes deployment. I've not changed anything from that. So whatever the Kubernetes goes by the doc.
So basically they are using this selector.
Yes,
And then route.
exactly, exactly.
Can we define some information like, I think they are using round robin rules, right?
This one, so when you define the route rules, they are not round robin. So they are different things. I can explain much more about Istio maybe once the session is done. So what I'm going to do is like I'm just going to run the v1, v2 this rule. I don't have anything. So let's check if everything is cleared. Okay. I'm back to my round robin, the default one which Kubernetes gives me, right? So what I'm going to do is like I have two browsers in my thing, Safari, I'm in Chrome and Firefox. So what I'm going to do is like I'm going to route all the traffic that is coming from Safari. So anything that goes with Safari, I'm going to say that take me to v2. So if you access from, say for example, from Chrome or Safari user agent based browsers, then it means that it's going to take me to v2. For all other stuff, it's going to go to the v1 of the recommendation service, right? So what I'm going to do is like, I'm just going to do the same thing, OC apply -f, right? The moment I do this, so what happens is that I'll just do a refresh here. You see here? So for my browser, it's going to go to v2, right? So in case if I'm going to copy the same access and then I go to Firefox, it's v1. Okay? So this is how it does. So it kinds of routes based on the user agents. If you see the example here, so I'm saying that it's another match apart from label. I say they match the request agent headers, and if it's going to be something like Safari, then route all to this particular version of the service. And if it's going to be something else, then you take the default one and go and deploy it there. Okay? So this is how the routing rules can be done. This can avoid all your operational efficiencies which we were talking about earlier. I'll just quickly go to the slide where I was talking about that. So this made us to do this kind of demo, what we saw right now. You can increase, decrease the percentage anywhere you want. And it also helped us to get around few things like we were able to do A/B testing for not exactly the A/B testing, but more or less with different browsers. And then I was able to do the Canary releases. I had v1 and v2. I was able to deploy them without any hassle. Probably the rate limiting and access policies we don't have. I will show you the tutorials which we have. So probably we can access those tutorials to learn by yourself and all that stuff. Okay. And then I'll make the last slide a bit longer because I'm sorry. I was there on the last slide. This is the most useful stuff, which I feel. So we have a lot of tutorials which has been done around. So this gives you the second link from the top is the GitHub repository where you saw all these demos. And then we are also seeing the Istio tutorial stuff, which is there, the bit.ly link, so which talks about how do we deploy Istio, what Istio is all about, and all other things. And also we have a learn.openshift.com/service mesh. You don't need to deploy anything locally. You can go to this particular platform on a browser, and then it gives you step-by-step instruction on how to learn Istio and how to deploy applications using Istio and service mesh. And this are also demos with here, and then we are also a bunch of other demos. So we worked on something called as Green Cloud demo. What we did is like we took this typical Spring Cloud application and we made a step-by-step deployment onto OpenShift and Kubernetes platform. So, and then we define like what all the things that's required for you to do the deployment, kind of migration. So that helps you to do these things, and then the demo sources are there. It's a typical Spring Cloud platform. And then there is a stateful canary using InfiniSpan. That's there. It's kind of a movie store demo, so which you can learn there, like how do I maintain cache within OpenShift, if it's going to be changing, doing rolling deployments and all of the stuff. Your cache still remains same. So these are the materials which you have, which you can go and see that. And I think I have 2 more minutes to take a few questions. Yes, please. So I leave this, okay. Yes, we can have Eureka instead of service within OpenShift. Absolutely, we can have Eureka. So the green cloud demo, which I showed you, initially start with deploying Eureka so that your application is deployed as it is, and then you can just change that out as well. Could we change the routes with no downtime under live traffic? So changing route, it's going to break, but how do you actually change the route? You can change the versions of the application rather than changing the route. The route could remain same. The service that is backed by the route, it's always changed by your application labels. So you can change the labels of the application service so that it could be done without any downtime. Right? Can OpenShift be used with Google Kubernetes? Absolutely, no doubt. So OpenShift can be used with any cloud provider right now. We majorly support GCP, Azure, and Amazon by default. So, and it can work even in your private cloud as well, or even private public cloud hybrid environment, wherever you want to deploy OpenShift. It's available there as well. Why didn't you use Go Fabricate? It's a good question. So I was using Fabricate earlier, and then the Fabricate platform is going to be enhanced and replaced with a different product right now. So it's going to slowly go out of existence. That's the reason why I did not show them. If you've gone to my repository, I have provided a link. If you go to that old repository of the Green Cloud demo, I would have used this Maven Fabricate plugin to do the job. But we are replacing that with a better tool. So that's the reason why Go Fabricate was not used. Some prefer to use Histrix with Spring Boot Kubernetes project. OK, Spring Boot Kubernetes is just a wrapper around your application project. So which means that with Istio, the what I call the circuit breakers are defined a different way, right? So it's more relied using bulkheads, if I'm not wrong, rather than the typical circuit breaking. So we have more sophistication there when compared to the typical circuit breaking that is there in the Istio world. I mean, in the circuit breaker world. Some prefer, I think. Any more questions?
Yes, last question.
That's it. Fantastic. I have 3 seconds. Good. Done. Thank you.